Hi, everybody. How are you doing?
I'm good. How are you?
I'm good, thank you. I'm going to do lab 4 today. So if you want to check out Canvas, let me turn on live caption. Okay, so let's check out Canvas real quick. We'll start in a few minutes, okay? Okay, so let me put share screen on. Welcome back, everyone. I hope you're doing good. We're going to work on lab 4 today, so please download the lab and open your simulator and editor. Okay, I think I'm caught up with grading for this class. I'll work on my CIS11, the other class, later tonight. So if you have something outstanding, make sure you get those to me. Okay, so we'll start in 2 minutes. Any question before we start? No question? Okay. So check out lab 4. Okay, so we're going to do a few things today in lab 4. As usual, we're going to use the simulator and the editor. So if you're using the online simulator, make sure you access the website and get ready. I'll start at 6. Okay, 6 now. So, okay. So today we are going to apply the concept that we touched on in the last couple of weeks, where we work with conditions and instructions and operation in LC-3. We are going to use and not, add, load, and store, and branch and jump. Okay. So I had modified the exercises from the original lab manual, and so this is what you see. And in this lab, we are going to write arithmetic functions. So expanding on what we have learned in the last couple of weeks, we have used subtraction. We have learned to apply comparison with branching and conditional statement in LC3. So in this lab, you're going to see more of that, and I hope to give you practice so you can get ready for your project later on this semester. So in exercise 1, it asks you to create the program, and it's given you the criteria that you have a variable X and a variable Y. And these two variables or labels, we want to put them at location hex 3120 and hex 3121 respectively. So that means that when we add the data section, we have to fill those. Okay, so that was given to you. We want to compute the difference in X minus Y, and we want to put the result in the location 3122. And just like the last lab, we want to keep them together so it's easy to see on the simulator. Now we are going to work with absolute value, and so that will be positive value. We want to place the positive, or I'm sorry, the absolute values, X and Y, at the location hex 3123 and hex 3124. So we have to keep them separate from the other values. Now, we want to determine which of X and Y is larger. So we have to do comparison operation there. And it asks us to place 1 at the location hex 3125 if X is an absolute value, and 2 if Y is or a 0 if they're equal. So if Y is larger, right, we want to put them in another location. So that last part, what it means is we're gonna put the 1 at 3125 if X is higher in value. Now, if Y is higher in value, we're gonna put the 2 in 3125, in hex 3125 location. And then if they're the same, we're gonna put 0. So we don't actually put the value, we're just gonna have to put those value that's asked, 1, 2, and 0 at the hex 3125. So the below table kind of give you the overall summary. We have to do the subtraction, okay? And that's at 3122 is gonna be the result. The absolute value is gonna go to hex 3123. Absolute value of Y is gonna go to hex 3124. And then your Z, which is gonna be comparison, that's gonna be at hex 3125. So how do we define Z? And this is important because when you see this, right, you would be able to create your branches or your branching based on what's given here. So for Z, we're gonna have Z is gonna be equal to 1 if absolute value of X minus Y is greater than 0. So that will be branching positive. And for Z is equal to 2 if X, absolute value of X minus absolute value of Y is less than 0, and Z is equal to 3 if X minus Y is equal to 0. So what we want is we want to be able to branch. And so for here, we wanted to use the branching and the target, okay? So that means that if the result in the previous instruction was 0, you would branch BRZ, okay? So in the previous line, the register, if the result is storing 0, you branch 0. Now the next instruction to be executed on the one with the label, which is target. So we want to use a label to be able to branch, right? So whatever says target here, we would replace that with the label. If the result is not 0, then the instruction is branch follow BRZ, target is executed, and the execution continue as normal. So if that doesn't check true, it's going to go to the next line. Okay, it's going to skip the branch. So a branch instruction depends on 3 conditions. We're going to have the negative, which is it's going to check for the negative value. Z is going to check for 0, and P is going to check for positive. So the value 0 or 1 at each of the condition is determined by the nature of the result that was placed in the destination register in the earlier instruction. So we always go to the prior line and we want to look at the destination register, what value it holds. And based on that value, it's going to branch accordingly. So if we tell it to branch to 0 and it's not 0 in that destination register, then it's going to skip the branch and go to the next line. And so you can actually combine the branching. You can do like BRZP, where it's greater or equal to 0, and so on. Okay, so here it gives you an example. When we read this, we should know how to do that. We have a lot of practice so far. So we're going to clear register 1. We initialize register 1 at 0. And then we are going to take hex 1 and we're going to add it to register 1. And we're going to put the result in register 2. Okay. So that means that for register 1, that's 0 plus a hex 1. So now register 2 has a 1, a hex 1. And so if you are branching at 0 to the label, it's going to check the value in register 2. Okay. Since that value is positive, right? Okay. Then if you branch positive, then it's not going to go to the 0 label. Okay. So when you branch, you want to use a label, whatever label you want to use, and it's not taking the action because register 2 is not 0. So it's going to skip the branch and it's going to go to the next line. Okay. Just like how you would treat an if condition where you say if, right, this value is equal to 0, then execute the body of that conditional statement. And so if it's not true, then it's going to skip that body and it's going to go to the next line. So here again, the table gives you various branch. We got the branch in the regular branch, that's a BR, where we can just send it to a label without any kind of value check condition there. BRZ is for 0, N is for negative, and P is for positive. Now, as I said, you can combine them. So you can do branch negative 0, so that or 0. So it would check for negative value or 0, negative positive, 0 positive, negative 0 positive. So you can branch unconditionally if you're using all 3. Any question with branching? Okay, so the clues that we're going to get for our program is going to come from here. Okay, and the reason I did give you the snapshot of my code, but I want to explain how that was derived, right? That was created. So when we input, we want to have some kind of input, and register 1 would have the X value. And the output is register 2 that would have the absolute value of X. Okay, so we would take register 1, add it with the decimal 0, and then put it onto register 2. Okay, then we are going to branch 0 positive to ZP. So if it is 0 or positive, it's going to go to ZP. And then we're going to subtract. So here is where we set up the 2's complement of register 2 because it's X minus Y, right? And your Y is going to be from register 2. Now we want to store the value back to register 2 to be outputting absolute value of X. So your R2 is negative R1 at this point. So we did the 2 complement there because we did a copy right at the top. Okay, so we copy R1 to R2, we branch 0 positive, right? And then we did the 2 complement of R2, which is also R1. So at this point, your R2 is an absolute value of R1. Okay. Now, this is just a snippet. It's not a complete thing, so we have to put everything together. Okay, and you can enlarge this. So what I'll do is, let me go here. So this is the program that we are going to write. And I want to go down line by line so you can understand. And you can add the comments accordingly. Okay. So we know that we have to work with X and Y, so therefore we are going to use labels. So first line first, we are going to have the origination address. We're going to start our program at the address hex 3000. So origination address is at 3000. Then we are going to load the label to treat X and Y. So we are going to do LDI R1X. And we are going to do LDI R2Y. And here, what we want to do is we are going to negate 2 and put it on register 4. So we are going to flip the bits for the 2, R2, which is Y, right? Because we're going to subtract. Can you use register 2? Yes, but down the line, I want to reuse register 2 for the output. So I decided that I would put the not on register 4. So this is going to be the ones complement. You can also put that. And then on the next line, we have to do the twos complement because we're subtracting Y, right? So here is your twos complement. So at this point, your R4 is equal to negative R2, or that could also be R4 is equal to negative Y. Are we okay so far? Any question? Now, then what we're going to do is we're going to take the X, we're going to subtract Y, and we're going to put the result in register 3. So you add R1 and R4, and then you put it into R3, or at this point, your R3 is equal to X minus Y. Any question? And so since we have R3 have X minus Y, we are going to store it to X and Y. So that means that X and Y going to contain result from X minus Y. Then on the next one, what we're going to do is we are going to copy, right, R1 to R4. And what is R1? Rx, correct? So now R4 has X. And I'm going to pause here. I'm going to flip back to this because this shows you how that's done, right? Because we wanted to copy it over and then branch. You see that? Okay, they give you the clue here. So when you copy it to the register, that register holds the value that you want to use to check the branch. So coming back here, this is why we do the copy here. And we want to branch 0 positive, so it's going to check for what's in R4. Is it going to be larger than or equal to 0? Okay. So here, what we're gonna do is we're gonna branch positive or 0 R4 of result in R4. So that's the previous line, destination register is R4. And then now we got to do the absolute value. Why are we doing that? Is because this is what's given to you here. So instead of R2, we're using R4, right? We got to subtract it because even if it's a negative value, when you put it into the absolute value symbol, right, that is going to treat it as a positive. So that's why you branching at 0 and positive. Okay. Question. So here, that's a 1 complement of R4, and we're setting up negative now. So 2's complement of R4. So at this point, R4 is going to contain a negative value, right? Which is what? Negative X. Because when you put this into an absolute value, so I should do this, negative X for absolute. Since you're branching to a label, you got to set up that label. Okay, you can tab it or you can do it right above, that's fine. Okay, so what we're going to do is in our label section, now it's going to be 0 positive of X, which is absolute value of X. This section is gonna, so we're gonna take what's in R4 and we're gonna store it to a label, because if you don't, you're gonna lose that value. Okay, that's why you have set up the operation right above it, and so that way you can store it to a label. So store absolute X to ABS X. And recall that register 2 has Y. Okay. So we're going to take Y and we're going to copy it to register 5. Copy R2, which is Y, to R5. And now we're going to use R5 to check. So why don't I use R2? Because I wanted to keep 1 and 2 intact throughout my program. Right? I want to use other registers so I can do the operation like negative and so on, as you can see, because we have to find the absolute value of X and Y. So this is why we need to copy so we can use the other register to do the operation. So at the next line, we're going to branch for 0 positive to check for the absolute value of Y. So here is why we copy. It's going to check Y in register 5 for the branch. Branch if Y is 0 or positive in R5, right? Now in the absolute value, it could also be negative. So what we want is we want to do the 1's complement of R5. And then on the next one, we're going to do the 2's complement of R5, which makes it negative R5 or Y. since we're branching to a label value of y. And we, just like before, sorry, my internet, I'm going to turn off my video because my internet is a little unstable right now. So here is where we are going to store, right? So we store y or result. Where did I put? Absolute y to ABSY. And recall that we had the 2's complement that was in R5, right? Right here. So now if we take the 2's complement of that, it would then come back to positive. So here we're going to do a 1's complement of R5 and put it in R7. And then we are going to have the next one, which is the 2's complement of R5 would put in R7, which makes it negative R7. Now we're going to add. So we call that your R4 is X, right? So we have to do X subtract Y. And put result in R6. So we checked for the absolute value already. Now we're going to check for positive and 0 and negative. Okay. So branch positive. And then, so if it's positive, it's going to go to pos, like what we did last week. If it's 0, send to pos. And then we can branch for 0. That will send to 0. Okay. And you want to use your label accordingly like this, so that way it's easy for you to see, because if you have a long program, it gets lost. Okay. And then you have, we're going to branch for negative, and we're going to send to NAG. So now in this section, because we branch for positive, we got to set up the condition, right? It's like how you would say, right, if it's like this, go here, but you have to define what that is. Okay, so this is going to be for your positive. So R6 is X minus Y, right? Okay, so if X minus Y is positive, then you would send that here. That's what it meant. So this line, what we're going to do is we're going to clear R6. And we are going to add 1 to R6. Okay, pause right there. Okay, coming back here. This is why, so here it talks about how when you're branching, clear the register, right? And they add the 1, and And this is going to allow you to check the condition for the branch. Okay. So in that, what we would see is that it's going to check the register. Now coming back here, because if it's positive, right, when we add the 1, it would stay positive. So that way we would then store it to Z, okay, which is your X minus Y. So then we would then store result to Z from R6. And then we would stop execution, then your 0 section. Since we also branch to 0 right above, we got to set up your 0. So if X minus Y is equal to 0, then we would do the following. Again, we are going to clear R6. We're going to add 3. Add decimal 3. So why am I adding 1, 3, and so on, right? You should ask that question. It's this. That's what we're doing. Because it tells you here that if Z is 1, then it's greater and equal to Y, right? We are not outputting the result. We're outputting a value that represents 0, positive, negative, and so on. So this is why we add the 1 here. Okay? And this is why we're adding the 3 here. Okay? Because I can see, like, when I look through this, and if I don't read that section, I'm going to be like, why am I adding 1 here and why am I adding a 3 here? It's because in the question, it tells you that if it's positive, you show 1 in the memory. If it's negative, you show 2, and if it's 0, you show 3. Okay? So this is why we're doing that. So if it's positive, we show the 1. And that's why we store it to the Z location. If it's 0, we're going to show the 3, the decimal 3. Okay. So let me add that, show at C. And then this is why we store result to Z from R6. Then again, we are gonna stop execution. Now we gotta set up the negative for the result X minus Y. So again, we are gonna clear R6. Why am I clearing R6? Because if I don't clear R6, R6 actually had value in it, which is in the prior, right? We want to clear R6 so we can put the value that we want to show if it's negative or positive, because we already store out the value X minus Y from R6 prior right here and in the previous. Okay. So then we are going to add 2, so mode 2 to show at C. And then this is why we store result to Z from R6. And in the next line, we are going to stop execution. So now we have our data section. That's easy. cleaner. Okay, so in the question, it tells us to fill X at 3120. Okay, Y at 3121, X minus Y or XMY at 3122. Absolute value of X or ABSX is at 3123. ABSY is at hex 3124. And then Z is going to be at hex 3125. And after the data section, we end our program. Are we clear on this? Any questions?
Professor, are branches the same or similar to conditional statements? Like if
Yes.
okay, just want clarity. All right.
Yeah. Yeah. So it's gonna it's gonna check the destination register, and we only work with numbers in assembly. So just like how you would say, if X is 0, right? Go here, do this. Show 2 or, where show 3, etc. That's exactly that. So after you're done, you're going to go save as, right? And then we can assemble, make sure there's no errors. Now you can have the label like this, or some of you might want to do a tab in. So you can have a section like this and then following, so it's easy to read. However, that will be easy for you to see. Okay. So keep in mind that when we branch, we learned that it's going to check the previous line destination register. And as you look at this, right, we want to clear and show a certain value based on the condition that was stated in the question. So when you look at that question in your mind, right, you should be able to pseudocode it real quick. You would say, oh, well, then I would set up these branches that will go to these labels. And in the labels, I would clear register, add the value, store the value to the location, which is another label. And then I fill at the end. So as you can see, just a simple equation, absolute value of X minus Y, but because we are required to fulfill the conditional criteria, we have to set it up like this. So after you assemble the program, if you're using an online simulator, you just simply load it on there and run. And then we can just open and load the file. Let me get my unit 4 in. Okay, so this is your program that you wrote, right? And as you can see, we start at hex 3000, and then it puts, right, each line is going to be at each of the address, which takes up 16 bits. That's your word size. And then your data is down here. And we fill the data, right? So I put down some instruction for you to do so that way you can utilize your simulator a little better. So in step 3, right, so you can run the program, you can look at the locations and so on, but it says to use the step over button to go through the program. and answer the following question. Identify the registers that are loaded at the beginning of the program. Double click each line and specify the location for each. Continue to step over program and try to identify the trap vector. And it's just, I'm not asking you to answer the questions yet, right? We're just gonna fulfill those procedure. And then in step C, you are gonna look at the simulator and you are going to use the jump to drop down arrow, right? And you're gonna come back to the hex 3000 and look at your program code. So look at the label and look at the value in the register. So as you step through the program, you will see that you're gonna see the data being moved, okay? So instead of clicking run, you can use these buttons up here. You can do a step over, a step into, and a step out. So let's do a step over, and we're gonna have to click through each of the steps, just like how you've seen in C++. So as you look at this, right, pay attention to what it's doing. So now we went from the origination, we went down to the 3001. That's the first step, right? So after that, we load the R2, which is Y, okay? And then we would go through to the next one, right? See how your program counter changes? Remember we talked about the program counter and how it adds the register values. And so the simulator, it's designed to give you the visual aspect of what the processor is doing. And then in the next step, okay, so at R4, see how it's gonna be here. So it's gonna give you that -1, and then step over again, and so on. Okay, you can also put your breakpoints at some part of your program so you can check. So these buttons are designed to give you ways that you can check some of the steps or each of the steps. Okay. And then I showed you last time that you can jump to certain part of the program by simply using its address. So after a while, you can go through and then you can jump. But if you look so far, as you can see, right, I'm not getting any kind of data, or I can't see anything in register. The only changes I see is in here because we are stepping over and things have already been passed through the register. Okay. Now, if we run, right, at the end, it's going to be a -1 because it's got to move back on the PC. So and sometimes you would see the register would hold a certain value. Okay. So now if I jump to 3120, right, and I want to check to see if, you know, a certain value is there, but we didn't set a value. So if you do set a value, you can check what X and Y is. Okay, so how do I set a value based on this program? Sorry about my dog. She's excited about the doorbell anyways. Okay, so how do I set the value? You can go to set the value for X. Okay, so you can set the value for X, right, at that location and the value for Y at the next location before you run the program. Okay, and then after you run the program, you can check Z, okay, and the other locations. So let's try that. So every time I like to reinitialize the machine because sometimes there's remnants of data that's there. And then I'm going to reload the program. Then I'm going to go ahead and click the set value. So I want to set the value for my X, which is going to be at hex 3120, and let's give it a low value. So let's say I wanted to have a 4. And then for the y, I wanted to set it at 3121, and I'm going to subtract 3. All right, so once we set those, we're going to go ahead and click run, and then we're going to jump. Okay, so here we saw that we had set x is 4 and y is 3. Okay, now the absolute value of x, it shows a 1. The value of y, it shows the 4. Okay, I'm sorry, x minus y is 1, of course, because 4 minus 3 is 1. The absolute value is 4. The absolute value of y is 3. And then your result for z is 1. And recall that when we come back to what it asked us earlier, right, a 1 is that x is greater than y. Okay,
My result for Z came out 0.
so you might have missed something. Check. So if it's 0, then check your positive section.
I'll check that.
Yeah, so I would check this section and then somewhere here too. Other questions or comment?
Hold on, what was the step you just ran through? Like, what did you add? Because I know you added did you only just add the 4 to location hex 3120?
Yeah, so let's do that again so you can see. After you load your program, you click the set value
Okay.
before you run, and then you want to specify what x and y is at those location 3120. So I would start with x 3120, and then I gave it a hex 4 for x. Click apply. Then at y, which is hex 3121, and then I gave it a 3. Click apply and click OK. Then I run. So it's going to bring me to the later part of the program. You want to jump back to the location that you set. So jump to 3120.
Okay, now I got the values.
Yeah, so you can see that your x is here, your y is here, x minus y, your absolute value of x, your absolute value of y, and positive, right? That shows a 1.
Yeah, I made a simple mistake. All I did, like, I literally didn't click OK after I applied the changes, so it didn't register.
Yeah, so you have to confirm it so it would put it into the location, and then you run. Now you can test it with a larger hex value. Just keep in mind that, like, you know, you do have some size restriction as we are working with 16 bits and things like that. So you can put like a larger value. I use a small value because mathematically we can do it really quick in our head, but you know, you can check with the calculator if you're using a larger value. Okay. So that's number 1. Any question? It's fairly simple, this one. So when you read that, oh, I see a chat. How do you set the value for the online simulator? Okay, 1 second. Let me stop sharing. Let me go back to open that up. Let me see. So while we're doing this, you can do the step over. Set our register jump.
Quick question. Do you want the step over in the screenshot too?
No, it's fine. Just you know, you can set the value and test it. That's good
Okay.
enough. Yeah, I think I put that just to show you how you could do it if you wanted to check every step and look at what it's doing. Okay. Hold on, let me see if I can jump to PC. Let me see here. I'm trying to see how they did this. So 1 second. Control file. Yeah, on this one, it only gives you move the program counter here or set breakpoint. Let me see if you can do, you can step through it. You can continue execution after pause. Clear buffer. Oh, I see. Okay, so let's check. Let's see. Yeah, so, okay, I got it. It takes a little bit because trying to think of how the designer put this together. So how you set, Ethan asked to really put a value before you run. So load your program in there, right? And then you click this arrow to go down to your memory address that you need to set. And then you click that memory address and then you type in, or you click the data section of that memory address, and then you put in the value, and then you click the check. That's how you set it, Ethan. Okay, so what I did was let's close this. I just moved down to, so let's say I need to set at hex 31 to, there I go, all the way down, right? To 31. Let me see, I think it also has a jump to section. Yeah, jump to PC. Oh no, it doesn't. So you just gotta click this all the way down to 3120 whatever, and then you click this and you type in the hex value and then you check and then you look. Yep. It's a little tedious because it doesn't have all the additional buttons, but the interface it should allow you to. Yeah, you can search it, yes. Oh, here, thank you. I didn't even notice that. That helps. Thank you, Sean. Yeah, good. So that's if you use an online simulator. Okay, any other question with one? So one screenshot's okay. You know, you can retest it with different value, like try a negative number, remember, keep it all hexadecimal when you set values. Try larger and smaller numbers to see kind of, you know, because you want to test the limit of your program and see if it, you know, if there's any issues. So if it's giving you some funky result, right, think about like what area you need to fix in order to get the accurate result. So sometimes, you know, if we add a value where it shouldn't be, right, we have to trace our step back and look at that. Okay, so with that, we can move on to number 2 if you don't have any questions. Okay, so this one is similar to what you've seen in the prior lab, where we compare the two variables. But and it's also kind of like what we've done in the last one, but since the last one is an absolute value, this one is simply just doing an extraction or subtraction, and then put the value in the result like the last exercise. So we're going to use the reference from exercise 1. We're going to make an LC-3 program that's going to have P and Q. So we have two variables, and the third is going to be our result, which is where we're going to store. So we would have a P at 3200, a Q at 3201. Your RES is going to be at 3202. And here's our branch, right? So when you see this, you say, oh, okay, so I just need to take whatever that register is, subtract this register, and then branch it to from the destination register. So if it's greater than 0, we're going to show a 2, like what we did with the Z in the last one at RES. And then if it's less than 0, right, we're going to do a subtract 1 from RES. And then we are going to have, if it's equal to 0, we're going to add a 1. So it's going to show a 1. Okay. And the labels, you can have it in the subsequent location from 3200. So however you wanted to use the additional label, you can. And we wanted to test it with 4, 5, and 3. Okay. So you can set RES at a certain value, because if you take 3 plus 2, you should get a 5. And then if you subtract 1, okay. All right, so let me get my editor up, and I'm gonna go ahead and open exercise 2. My internet is a little spotty tonight. I don't understand why. Okay. Probably no one's really using internet outside of me right now. Okay. So let's go through the program together. I don't know, did I give you a screenshot for this? No, huh? I might have okay, so, but hold on one second. Let me see if I can do this right now for you. So in case it's really small on Zoom sometimes. Let me drop it in the chat. Oh, it went through, so you should see it there. In case it's too small for you to see. All right, so we start with origination address. That will be at hex 3000. We are going to clear register 1 because we're going to use that. And I like to clear register when I start, just good practice. Then I'm going to load the first variable, which is P, to register 1. Then I'm going to clear register 2. After that, I will load Q to register 2. So after a while, you're going to see it's the same thing throughout. So we got P and Q loaded after we clear. Okay, so now we're going to do the operation. So after we have the Q, we are going to set up minus Q because we have to do P minus Q. So we're going to do a 2 complement of R2. Oh, I'm sorry, the 1's complement of R2 by doing the not. And then we are going to do we're going to add a 1 for the 2's complement. So R2 is going to be equal to negative Q. Then I want to load RES. Let me see if I need that. Yeah, okay. So I load RES to register 3 because unlike the other one, you can just store it directly, but we are doing arithmetic with that location as well. So we have to load it to register 3. And then we are going to use register 3 as our destination register. So we are going to take P. Is RES is P minus Q. And then we are going to check to see if it's positive, negative, or 0, right, or equal. So it's going to check in our register 3 here. So we can branch P for positive. So if P minus Q is greater than 0, it's going to go to pos. Then if it's subtract, and if it's negative, P minus Q is less than 0, it's going to go to neg. And then we're going to branch for 0. So if it is equal, it's going to go to equal label. And based on the question, it tells me that if it is positive, I'm going to take the result and add 2 to it. Okay. So here's my pos, and you can do it this way, or you can drop it down this way, right? You can put it next to each other like this. That's up to you. So I have a pos label, and I'm going to take 2. I'm going to add it to RES and put it back on register 3. So I can store it again to the location. Then I'm going to store it to RES. Then I stop execution. Then for my negative label, right here, I'm going to clear register 4. And I wanted to add 1 to register 4. Why am I doing that? Because I have to subtract 1. So then in the next step, I'm going to do the 1's complement of register 4. And then the 2's complement of register 4. So by that line, your register 4 is negative 1. And I would take that negative 1. I need to add it to RES, which is in register 3. So we would then add R3, R3, R4. So P minus Q is less than 0, then R3 is RES minus 1. Then we're going to store it out to the location, which is the label RES. And then we stop execution. So in the next label, which is equal, I need to add a 1 to RES. So we would have equal, then we're going to have to take 1 and add it to R3, which is RES. And then we want to store R3 back to RES. And we're going to stop execution. Then our data section, we just have to fill P, which is at 3200, Q, which is at 3201, and RES, which is at 3202. And we end the program. So after we have it written, we would then save. And then we can click the ASM button to assemble. Make sure we get 0 errors. And then we are going to load this program to our simulator. Let me reinitialize it. And we can set the values just like what we did with exercise 1, but in our assignment, right, it tells you to set 4, 5, and 3. So P is 4, Q is 5, and RES is 3. And then you can test the program. Remember that RES also have arithmetic. So do that. We're gonna go to hex 3200. Oh, no. And then the 3201, you're gonna have it at hex 5. And then 3202, we're gonna have it at hex 3. And then we run. Then we're gonna jump to so because it's negative, right? 4 minus 5, because 4 is less. So it's gonna take the value, which is -1, and then subtract 1 again. So as you notice, it's gonna trap there. And we'll talk more about trap in the later weeks too. You can see a little bit more when we get into stack. And then you can also test it with what the question asks you, you can do. So if we want to determine initial value is 5, so you can do P, and P is 7 and Q is 10. Remember that this is decimal, so you can set it with the hex. So whichever value you want to use, you just want to check to see if your program is accurate. Okay. And in this right here, you do see that there are some things that are left, but when you finish your program, your R1 is always going to be -1 as it moves down on the counter. So it has to subtract that. Okay, so give me a screen capture. So after this week, we should feel really comfortable doing comparison, because in the future lab, our programs are gonna get longer as we are gonna do Fibonacci and recursion and so on. Okay. Any question with exercise 2? Not bad. Now we can think about like how we would improve the program. What can we do better with this program? You can definitely have another iteration of the program that will be better, right? And I remember I threw this together real quick, so it's not like the best. So sometimes you have another look at it. You're like, oh, maybe I can do this. Okay. So like we talked about before, if you load, you need to store later. We see that in this program. Okay. And in the future, we'll start with store and then we're going to do restore. So. All right. Any question with 2? So you can set your value and check. All right, so we have to do additional comparison. So we would have number 3, which is we are going to do D plus C is greater than 10. And C can be equal or greater than 10. You need to use branching. This is very easy actually, right? So you should start first think about, oh, I'm just going to load D, I'm going to load C, right? And then I'm going to bring 10, decimal 10 into a register. So then I can add, and then I need to branch to compare by subtracting. And then I got to make sure I check that C is equal or greater than 10. Okay. All right, let's look at number 3. Oh, I don't think I wrote it in. 1 second. I think I wrote it in Word. Give me a second. I did. Okay. I remember doing this in Word so the student can see because, all right, so I'm going to comment it as I go so you can see. We would start with clear R1. Then, oh, sorry, I forgot to tell you the origination address. So .org x 3000, don't forget that, because otherwise it won't assemble. Then we're going to load D, which is the first variable to register 1. So here we are loading load to R1. Then on the next one, we're going to clear R2. Then after that, we are going to load C to R2. So I clear and I load. So now I want to represent C is 10 decimal or hex A. So since C is in R2, we're going to add it with, you can use decimal 10 or hex A. So I chose to use hex A. So I would do a hex A, add it with register 2, which is C, and that will be at register 2. Then next line, I am clear R3. And again, I'm gonna make R3 is equal to hex A or 10, right? And then what we'll do next is we are going to add D plus C to put it on register 1. So your R1 is going to be D plus C. And let's look at this again, right? We want to see if this is greater than 10. So we have to compare, and C could be 10 or higher. So that means that after we have D plus C, okay, we have to find ways to compare and we need to subtract. Okay, because you can subtract hex A directly, but since I put hex A in R3, I'm going to subtract R3. That's what I'm doing here. Okay, so here is the ones complement of R3. And then on the next line, I'm going to do the complements of R3, which is at this point, it's R3 or negative hex A. So if I subtract 10 with 10, and that means that if it's the same, then it's 0, right? Because in the question, it tells you that we want to compare if it's greater. So if it's positive, then it's greater, right? If it's 0, so we want to check for 0 or positive for C, and then positive for D plus C. So that's why I wanted to have the negative hex A here so I can start subtracting. So after that, I would subtract. I would take R3, add it with R2, and recall R2 is your C, right? Yeah, I'm sorry. R2 is your C, which is hex 10. So I'm taking a 10 minus a 10, and I can check to see if it's positive or negative. So at this line, when I add it, I go to 10. And since I have the destination register that would store the result for the check, I would branch the negative and 0 for C positive. Then I need to also check for D plus C is greater than 10. So I would take register 1 plus register 3, that will be your D and your C, and put it back into register 1. So we're going to check the result for D plus C from here. So D plus C minus 10 is this. Okay. And then we would branch it to the positive. Now, if it's positive, then it's going to go to the pos. If it's negative, right, it's going to go to the neg. Then we're going to show a 1 if it's positive, or we can even show the value if you want. So here I just simply want to show a 1, and I store it into the result, just like the last 2 exercises. I think even on this one, because if we're only checking if it's greater than 0, you can omit negative section, but I wanted to complete the if else statement. If it's positive, go here and do this, show 1, right? If it's negative, do this. So that's why I included the negative, but you don't really have to do that because in the criteria of the question, it's only checking for positive. Okay, follow so far as the positive section, we want to show 1 if it's positive. Okay. And then since we have a neg, so we would then have a neg section. And then we would clear, let me see. Paragraph 4. And then let's say that we want to show 2 if it's show 2 if negative. And then again, you just do an STIR for RES. So 2 RES. And this, you can actually halt right here. I forgot to tell you to do that. And then we fill the data. So you have C and D. So D, we can do a dot fill. And we can have it at, let's say 3100 or 3150. Let's do 3150. And then C, we can do a dot fill, hex 3151. And then RES, we can do a dot fill at hex 3152. And we will do a dot N. Not very good. Let's do 120. Okay. So in this one, you can see that, oh, I forgot. This is, we didn't have another section. It's going to throw an error. So let's add it right here, C pass. So if it's branching 0 positive for the C, if C is, let me look at this again. I'm missing a section. Equal C is greater than that, C is that. So here, if for our C pause, okay, we can just do an add R4. So when's that? Actually, it's just going to store to another label. So if it's greater or equal to 10, branch to C pause. And then we're just going to add it so that way. So we should just, if it's 0 or positive, right, we simply just gonna operate the add and we're gonna store that out. Register 1. And then we can do a I'm trying to see if that's the best. Store result to that. Okay, that's right. So we can keep everything else the same, because if you branch up here for 0 positive, right? So what we're doing is if it's 0 or positive for C, it's gonna still take D plus C, right? And then store it into the result. And then, but if it's negative, right, it's just gonna show the 2 with the result. And then if it's positive, it's going to show the 1 with the result. So you can have it however which way you want, because the criteria just basically tells you to use the comparison operator to check for if it's greater or equal to 10.
Do we need an address for CPOS?
Yeah. Yeah, you have to fill that. So let's fix this and make this 3. For the CPOS, yeah, you can fill it. It's going to show some value there, but we don't really check this, right? Ultimately, because if you really want to check to see if the result is going to be greater than, it's already in the next line. Okay.
I just got an
Yeah.
error message trying to fill the CPOS.
Yeah, I don't think that you need to, because it doesn't because we didn't fill the pos and the neg, so you don't need that. I don't need you only fill it to the location if you need to check the values. You understand? Like result we need to look at, X and Y, or C and D we need to look at. So yeah, I don't see the need in that, because otherwise we would have to do this. When you branch, you don't have to fill. You only fill if you need to store. Does that logically make sense? Yeah. So, but you have to have a CPOS section if you branch it, right? Like if I have a CPOS up there, and if I don't branch it, I mean, I don't have the defined section here, it's going to throw an error. It's going to say that, oh, hey, you send me here, but I don't know what that is, right? And it's all about going from one location to the next in the memory.
Professor,
Yes.
do we have to add a halt instruction after the CPOS branching?
Yeah, ideally, yes.
Oh.
You should after every branch, because what that does is it just stops it from going, especially when you're dealing with loops, right? Because when we branch in loops, sometimes like when you have a while loop, if you don't let it exit, it just runs forever, right? So in this case, if you don't put a halt, it's still gonna be fine, but practice, you should put a halt in, because when you do a for loop or a while loop, it's better that we stop execution, and then so that way it can move on to the next line. But since it's at the end of the program anyway, right? But if you have the CPOS section earlier, you can, then we just halt, and then we have the subsequent section for positive, negative, and so on. So your class is the only class that I fully solved this one for, okay? Because the prior class, I only did it up to the C. As you can see, I only did it up to that, so they have to do the rest, okay? And then the years before that, they just have to, I did the other one, so so if you do the first two, this one is similar to those. You just have to think about like, oh, how do I compare? I only compare when I would compare using subtraction. And you just have to introduce the value, choose complement it, so add it as a negative to the other value in the other register, and then branch. That's it. It seems complex, but after a while, it gets a lot easier. So the important part is you just have to track, right? Like what value is at that register at that point. And then if you need to clear it, you can. Okay. I could clear a lot of these stuff throughout, but that would just add a few more lines. So you can follow number 2 or number 1 that we did. Okay, other questions or comment? Okay, so that would be, let me see, that was it, right? Now, transitioning from this, let me give you a hint on what we're going to be doing next week for the lab. So I want to remind you that on the, let me see. Next Tuesday, we're not going to have a live session because I have to present to the board and they meet once a month for March. So I will have my recording up. So you just watch the lecture video, but I will walk you through the lab as usual on Thursday. Okay, I think they booked me for 2 to 7, so I'm not able to have your class. I did try to get out of it a few times, but I have to present some of the things that the programs and things like that to the board members. So hold on, I modified this. So we are going to do some cool stuff next week where we're going to work with calendar or days. Okay, and we are going to output some strings. So, the user enter a number and it's going to tell them the day of the week. Okay, so I'm going to show you how to do this so you can start thinking about how you can implement some of this to your project down the line. And we are going to do the month of the year. This one is hard because you will see that when we do the exercise that we only have 7 days in the week, but when we're dealing with 2 digits, right, it is a little bit more challenging. So we will address that on Thursday. So in lab 5, it is a little bit different. So the arithmetic part, we've been taking care of it in the last couple of weeks. We'll come back and use some of the equations when we start working more with the calendar. Like you can enter your birth date and it will tell you what day it is in the year that you were born. Okay, so we will do something like that down the line and using a Zell equation. So I'll share that with you on the technique on how to do that. Okay, so this is the lab for next week is a little bit different. So I encourage you to practice and use your resources like the prior lab, go through it. And if you don't understand something, please reach out to me and I can meet with you during office hours or something like that. We can go over things and I hope that I can help you understand it better. Because I realize that, coming from C++, Java, or other languages, this can be very foreign. But I hope that when we practice like this and I explain it line by line, it helps you. And if you go back to it, it will clear up some of the things. And as you set values and check your program, right, you would see why certain things is, why we do certain step or certain instructions and so on. Okay. Any question? Okay, so read the next chapter for the next week. Hold on. I want to remind you too. Okay, do the extra credit. So take the extra credit quiz game. That's going to help you prepare the quiz. Don't forget about our quiz, which is chapter 1 through 4. There's some binary and all that stuff that we cover from the beginning, some concept things. So if you do the game, it's going to give you a lot of the hints for the quiz. And then everything is due by Sunday. So make sure that you get those to me. So if you don't have time to finish some stuff, drop me an email and let me know. If you need some extra time or something like that, that's totally fine. Okay. So any question? All right. So no live meeting on Tuesday. Let me stop share. Stop recording real quick.